If you have not gone and read through the notes sheet, I need you to turn off this lesson and make sure that you understand all of the terms because I will not be going over them during the lesson. The two images that you see here are actually in your textbook. You can find them on page 501. And they just show different types of sequences that can occur in the real world. Daily temperatures are a sequence. If we have values of investments, that's a sequence. Distance traveled per hour, bacteria growth at different stages. What you can notice is that sometimes there's absolutely no pattern whatsoever. Sometimes we can see that the pattern is that we add a number each time. Sometimes what we notice is that we multiply a number each time. Each one of these is considered a sequence. However, there are special types: arithmetic sequences and geometric sequences. These are the kind where we can actually predict future values. Here we're given two arithmetic sequences. Please note that the word is pronounced arithmetic, not arithmetic. It's an arithmetic sequence, and we're asked to find the common difference and the next two terms. So from 9 to 7, we subtract 2. From 7 to 5, we subtract 2. From 5 to 3, we subtract 2. So the common difference is -2. We can also call this D. So if I'm going to find the next two terms, I say 3 minus 2, that's 1. 1 minus 2 is -1. Unless we are told that this is a finite series or finite sequence, this can go on infinitely, which means that we can have positive and negative values. Taking a look at the second one, we need a common difference again. So from 3 to 4.5, we add 1.5. From 4.5 to 6, we add 1.5. From 6 to 7.5, we add 1.5. So the common difference here is 1.5. So when we find the next two terms, that's 9. And then 10.5. When we look at geometric sequences, we're looking for a common ratio. So first we'll say 20 over 40. That's a half. And we'll check the next set of terms. 10 over 20 is also a half, so we can say that the common ratio here is 1/2. So when I find the next two terms, 10 times 1/2 is 5. 5 times 1/2 is 5/2, or we could call that 2.5. The next one is definitely more of a challenge to see, but we really can use the same process. We can say 6 divided by the square root of 6. We, of course, have to simplify this. And the ratio there is square root of 6. I can do the next two terms, which is 6 root 6 over 6. So my common ratio is the square root of 6. To find the next two terms, I will take 6 square root of 6 times the square root of 6, which is 36. 36 times the square root of 6 is 36 root 6. This next set of problems actually gives us a formula for the nth term, a t sub n formula. What we are asked to do is to calculate the first 4 terms and then determine whether or not our sequence is arithmetic, geometric, or neither. So what I might do is create a column with n, and the t sub n value, and in the middle I will do the calculation. So this becomes 1/2 times 1 minus 1, and that gives us negative 1/2. 1/2 times 2 minus 1 is 0. 1/2 times 3 minus 1 is 1/2. 1/2 times 4 minus 1 is 1. So now I'm looking to see if there's either a common difference or a common ratio. My common difference here is 1/2, which means that it's arithmetic. So to find the next 2 terms, I don't even have to do that. If I was going to find the next 2 terms, I would say 1/2 plus 1/2. 1 plus 1/2 would be 1.5, and then 1.5 plus 1/2 would be 2. But we don't actually need to do that. Taking a look at the next one, I'll make the same columns. One squared minus 1 is 0. 2 squared minus 1 is 3. 3 squared minus 1 is 8. 4 squared minus 1 is 15. So if I look for a common difference, there's no common difference. If I look for a common ratio, I have 3 over 0, 8 over 3, 15 over 8. So this would be neither. Taking a look at the last problem, again we're given a formula. This is 2 to the power of n minus 1 all over 4. So 2 to the power of 1 minus 1, that's 2 to the 0 power, and anything to the 0 power is 1, so that's 1/4. 2 to the power of 2 minus 1 is 2 to the 1, which is equal to 2, and 2 over 4 is 1/2. 2 to the 3 minus 1 is 2 squared. 2 squared is 4. 4 over 4 is 1. And then 2 to the 4 minus 1 would be 2 cubed. That's 8. 8 divided by 4 is 2. So if I'm looking for an arithmetic sequence, here I would have to add a 4th. I would have to add a half, I would have to add 1. So there's no arithmetic sequence. Is there a geometric sequence? So we would say 1/2 over 1/4. If I copy dot flop, that's equal to 2. 1 over 1/2 is equal to 2. 2 over 1 is equal to 2. So our common ratio is 2, and that makes this geometric. On this final problem, what you'll discover is that there is no geometric or arithmetic sequence here. However, if we look at the differences, we have a difference of 3. Our next difference is 4 from 8 to 13 is 5, from 13 to 19 is 6. So what we can do is say, because there's a pattern here in these differences, what I know is that to find my next term, I would have to add 7. So my next term is 26. We won't write a formula for this, but we can use this pattern to figure out what subsequent terms will be.